Okay, so yesterday we were talking about congruence relation, right? So if you look at this particular example, so so in this case, what is the relation? Two integers, right? A and B are integers. A is congruent to B modulo n, means n divides B minus A. Fine. So I will try to prove this. If A is congruent to B modulo n and C is congruent to D modulo n, remember n is a fixed number now, right? It is, and as we discussed yesterday, A congruent to B is equivalent to A related to B with respect to our relation, and that notation, congruence notation we are using here. So proof of this is very straightforward, so I think you must have done this, right? For first is easy, right? First one is easy. So A is congruent to B modulo n means what? N divides B minus A, and so that B minus A is n times some k1, right? For some integer k1. Now C is congruent to D modulo n means what? N divides D minus C.
D minus C.
Right. Therefore, D minus C n times K2. Right. For some.
Sir, you are not audible.
Is it okay now? Can you hear me?
Yes, sir.
Yes, sir.
Sometimes it happens due to internet connectivity, so don't get panic. So anyway, so A congruent to B modulo n means what? B minus A is n times some integer, so n is a B minus A is multiple of n. C is congruent to D modulo n means what? D minus C is a multiple of n. Right. So from this 1 and 2, let us call this as 1. So okay, so from 1 and 2, so from these two expression, what we can say? Okay, from this 1 and 2, what we can say here, this board is, the problem is with board, so just wait. Okay, so so there is a problem with board. So just a minute. Okay, so let us call this as 1 and this as 2. Now from 1 and 2, if we add 1 and 2, adding 1 and 2, so what we get if we add 1 and 2? So please keep your mic off. Somebody have kept mic on, so it creates disturbance. So from 1 and 2, if we add 1 and 2, expression 1 and 2, so what we get? b minus a added with left hand side d minus c, and left hand and right hand sides are equal, right? So therefore n times k1 plus k2. Now k1 plus k2 itself is a integer. Sum of two integers is integer. So n times k. What is k is k1 plus k2, and it is also integer. So what does it mean? So just simplify this. Uh, if we simplify these two, so what we'll get?
B plus D minus A in bracket A plus C.
Uh, d, what we want? A plus c. We want a plus c. So okay, what is it? B plus d
Minus
minus
in bracket.
a plus c is equal to n times k. But by symmetry of this congruence relation, a plus c minus b plus d is n times some k3, right? What is k3? Minus k, and still it is integer, correct? I am just changing the sign. So see, don't forget to keep your mic off, right? So don't forget to keep your mic off, otherwise it creates disturbance. I should not tell this again and again. Okay, so this is correct. That means this number minus this number is multiple of n, and therefore by our congruence relation, a plus c is congruent to b plus d modulo n. So this is very important property of congruence relation. Now second, if a is congruent to b modulo n and c is congruent to d modulo n, then what we want, AC is congruent to BD modulo n. That is what we want. If A is congruent to B modulo n and C is congruent to D modulo n, then what we want? What we want, AC is congruent to BD. That means we can multiply these two congruences. That means n divides AC minus BD. This we want. That means what we want, AC minus BD is equal to n times K for some integer. This we want, right? We have not proved this. We want this. Okay, so how to get this? AC minus BD is multiple of this. So uh, uh, A is congruent to B modulo n is equivalent to saying that B minus A is n times K1. That is clear, right? And uh, C is congruent to D modulo n is equivalent to saying that D minus C is n times K2 for some integers K1 and K2. So how to get a C and BD? So let us call this as expression 1, expression 2. So multiply 1 by C and 2 by B. Why I am doing this? Because I want something, I know what is expected, right? I know what is expected, and so in view of this expected expression, I am doing this step, right? So logically what I am doing, or how to decide, suppose you want to achieve something, and then you know the your target or your aim, your goal, And looking at goal, you decide your strategy. So I am looking at my goal. My goal is AC minus BD is equal to n times some integer. This is my goal. Looking at this goal, I am deciding my strategy. Right. So I will multiply first expression by right and second expression by B. So that what I will get, BC minus AC is equal to NC K1. Is it correct? Check whether I am writing correct or not. And
Yes, sir.
now I am going to multiply second by B. So BD minus AD, right? So BD minus what is
Sir, there
CD.
Sir, it should be CD. CD minus C.
BD minus BC, right? Correct? BD
Yes,
minus
sir.
BC is equal to N times what is here?
CK2.
P times K2. I am multiplying
BK2.
second,
Sir,
right? If your mic off. Okay, now this is correct. Okay, so I have multiplied by first expression by and therefore throughout I get C. I multiplied second expression by uh, B. So throughout I get BD, BC and here NBK2. Fine. What is my expected? AC minus BD. Fine. Now I will add 3 and 4 or subtract, doesn't matter. So now 3 plus 4. I will add these two. So I will add LHS, then I will add RHS. So BC minus AC plus BD minus BC. What is the sum on right hand side? N is common. CK1 plus BK2. That would be the bracket. But BC is common. It will get cancelled. BC minus BC. What remains? BD minus AC is equal to n times some K4. What is K4? K4 is this bracket CK1 plus BK2 and still it is integer, right? So what is the conclusion? What is the conclusion?
N divides
BD minus
BD
AC.
minus AC.
That means n divides AC minus BD because when n divides BD minus AC, that means n divides its negative, which is AC minus BD. And what is the conclusion of this? What is the conclusion of this? AC is congruent to BD
BD.
modulo.
Modulo N.
this is
Right.
congruent to PD. Modulo.
So this is what we expected. We expecting this, right? So therefore, if A is congruent to B and C is congruent to D modulo N, then we can multiply these congruences. And therefore, from this we can generalize something. So if A is congruent to B modulo N and K is some positive integer, then A raised to K is congruent to B raised to K modulo N. Is it true? And I think no need of detailed proof for this. Why? What is the proof? A congruent to B modulo N and A congruent to B modulo N. Suppose I assume these two congruences. The numbers are same, but these are two congruences. Now, using previous second result, what I can say here, can I multiply these two congruences?
Yes, sir.
So what
Yes,
I
sir.
can say, A square is congruent to B square modulo N. Yes, I am multiplying like previous case. What doesn't matter what are A, B, C, D in this case. In any situation, this is true. A is congruent to B, C is congruent to D, then AC is congruent to BD. So in any situation, in particular, if my C is equal to A and D is equal to B, then also I can multiply. So a square. Similarly, one more times I will multiply these two. I will multiply these two. So what I will get? A cube congruent to b cube. Again I will multiply this with a. So you can take any power, right? K is a natural number, means k is 1, 2, 3, 4, 5, whatever. You take any power. So prove by induction. I think idea of proof is clear. So you should work out these calculations. Anyway, so what is my next point is uh, so uh, so let n is a positive integer fixed. I am fixing my n and I define uh, okay, for AB belongs to Z, define A congruent to B modulo n if n divides B minus A. That is what our congruence relation is. Remember, n is fixed. Then we know that so this, right? So what I mean to say congruent to B, that means A is related to B modulo n if n divides B minus A. This is my then is an equivalence relation. Right? So do you agree with this?
Yes, sir.
Because we have
Yes, sir.
discussed this. We work out the calculations for particular n is equal to 5, but you can work out same calculations for any particular n, right? So work out the calculations. So you should work out the similar calculations for any n, right? So this is an equivalence relation. Then the set of classes, right? So what is the set of equivalence classes? So set of equivalence classes, how do we denote this? Modulo this relation, right? And this is simply Z modulo NZ. Please keep your mic off. And how do we denote this? Set of equivalence classes.
Z suffix n.
Right, very good. Z suffix n. And what are the classes? 0 bar, 1 bar,
2 bar, 3 bar,
2 bar, 3 bar,
n
4
minus
bar.
1 bar.
n minus 1 bar, because n already member of 0 bar, right? N is a member of class of 0. Therefore, class of n is same as class of 0. Then what is the class of n plus 1? Class of n plus 1 is same as class of 1, because
1 bar.
n plus 1 is a member of 1 bar, right? And therefore, how many distinct classes we'll get? We'll get n distinct classes, right? So you work out the exactly similar calculations which we did for n is equal to 5, right? And I gave you exercise for n is equal to 7 and 6 also, right? Okay, keep your mic off. Who is this Gayatri? Then get mic on. See, I am telling same thing again and again to keep your mic off, it create disturbance. So you have to be very careful about this. right? So you have to be alert. You are not the dull students, you are brilliant students. So you have to be sincere and alert. So immediately keep your mic off because it creates disturbance and it is wastage of our time, right? Okay, so there are n distinct classes. So this is clear, fine. So now uh, now we'll consider, now we have what is Z5, what is Z5, 0 bar, 1 bar, 2 bar,
2 bar, 3 bar, 4 bar.
very good. So what is Z6, 0 bar,
0
1
bar,
bar,
1 bar, 2 bar,
6 bar.
4
and
bar, 5 bar.
5 bar, right? And
Bar.
6 bar is same as 0 bar, 7 bar is same as 1 bar because 6 is here, 7 is here, and so on. So now you can write all, and this is modulo 5, this is modulo 6, right? So equivalence classes modulo 6, equivalence classes modulo, uh, right? Now let us consider Z5, 0 bar, 1 bar, 2 bar, 3 bar, and 4 bar. Now my set is Z5, and what are the members? Classes. Now I want to do some arithmetic with this set, right? Arithmetic means what? Do you understand the meaning of arithmetic? Right? So I am going to work out some algebra, right? Algebra means what? What is algebra? I want to study algebra of this set. Means I want to what is algebra? Algebra means you have some operations like addition, multiplication, and so on, and how to study that particular set with respect to addition and multiplication. So I want to define additions, how to add the objects. Now what are the objects in this set? I am looking at this set as a set, and what are the objects in this set?
Classes.
Classes are objects now, right? Suppose you have various fruits. This is a this tray contains various fruits, right? There are all types of fruits, and on this set X I am going to define a relation. So fruit X is related to fruit Y if X and Y are of same type, right? So apple, bananas, all fruits are there. But when two fruits are related and these fruits are labeled with different labels, but two fruits are related if they are of same type, means apple is related to apple, and therefore there are 5 apples, right? If there are 5 apples, then what is the class of this particular apple? All apples in this tray, right? What is the class of, if I choose one banana, then what is the class of banana? All bananas in this tray, right? And then I will put all apples in a box and I will label this as A. What is my A? So A bar is class of apple, right? I will label this by B. What is B? B is a class of banana, right? Uh, so orange, this is a class of orange. So I will put all oranges in one box. And then what is my new set? What is my new set? My new set is uh, F. And what is my new set? All these boxes. All these boxes. And what is this class of apple, this class of banana, this is class of orange, and so on. And therefore what are my objects now? Boxes. Each box, one box is my object. Now I will treat box as an object, right? Like in natural numbers I will treat 1 as an object, 2 as another object in natural numbers, 3 as another object. So similarly I will treat this box as a one object, this class as a one object, another class as another object, So these are my objects. So the idea is clear.
Yes, sir.
Right, now what are my objects? What are the elements now of this set? 0 bar, 1 bar, 2 bar. These are elements now. Now I will not look this as a set. Intuitively I know that these are sets, but now as I am looking at this Z5 as a set, so the member of this set is 0 bar, one member of another member is 1 bar, another member is 2 bar, and so on. So this set has only 5 members. Right, so now I am going to define addition. Now we want to study algebra of Z5, and then we'll generalize this for Zn. Right, so we want to study algebra of Z5. But if you want to do algebra, what we need, what basically we need to study algebra, we need addition, multiplication, we need these operations, right? Because when you learn some algebra, you work with some expressions, and then the expressions involves addition and multiplications. Multiplications means powers and so many things, right? So study algebra of Z5, that is so that we need binary operations on Z5. Which binary operations? Addition and multiplication. Right, so do you understand what is my uh, intention is? I want to study algebra of this set, right? And why to study algebra of something? Why you study addition of numbers? Did you worried about this? Why you are studying addition of numbers? Why you are studying from school, from first standard? Why you studied this algebra of numbers? Why you study addition, and why did you study multiplication, all these things? Why did you study? Because you wanted to understand that if you add two numbers or two elements, what is going to happen, right? Because you wanted to study that if you multiply two numbers, what is going to happen. Is it clear? This was the ultimate aim. Is it clear? Do you agree?
Yes, sir.
Right, and therefore what is the
But
addition
sir,
and
in algebra, we also use the subtraction and division.
what is the subtraction? What is subtraction? What is 5 minus 2? 5 minus 2 is basically 5 plus of minus
Yes.
2. Right, so there is nothing like subtraction. Subtraction is actually addition. We are adding 5 plus minus 2 is same as 5 plus some another number. That number might be, so this is a number minus 2. So basically there are only two operations, addition and multiplication. Right?
Yes, sir.
Right. So now define addition modulo 5. Okay, addition on Z5. Modulo 5, we'll see this later on as A bar for how we are going to define addition. That means how to add two objects, because here we have boxes, right? And how to add boxes, that is a problem. It is not like our usual way, right? If you have two numbers, if you have 5 apples and 3 apples, you can say that key 8 apples. That is easy, but we are going to add two members, these objects, and these objects are boxes, right? So for A bar and B bar in Z5, A bar plus B bar is C bar if A plus B is congruent to C modulo 5. Right, so what is the addition of A bar and B bar? addition of these two classes or these two boxes is a new box or new class. But what is that box or what is that class whose representative is C? And what is C? C is actually A plus B, right? C is congruent to A plus B. Who has kept mic on? Somebody, I think Vedangi Patkar kept mic on.
Sorry, sir, it was left by mistake.
Okay. Now, do you understand what is the addition? How we are going to add two classes? The addition of these two classes is a new class, and that should be a member of same class, same set, right? If we add two objects like real numbers, if you add two real numbers, we'll get the again real number. If you add two integers, again the addition of two integers is again available in. Similarly, if we add two numbers, two objects here, we should get the object which is in this set only, right? And what is that object? That object is a class of C. What is C? C is congruent to A plus B, right? And define multiplication on Z5 as for Z5 A bar dot means I will say multiplication means dot. For simplicity, I will denote it by dot, multiplication or dot. A bar dot B bar is equal to C bar if so what is the multiplication of these two objects? The multiplication of these two objects is C bar if AB is congruent to C modulo 5. Right, that means the multiplication of these two classes is a new class C bar. What is a C? C bar is a class whose representative is C. What is C? The A and B congruent to C modulo 5. For example, let us work out this. For example, in this case, 2 bar and 3 bar are members of Z5. Am I right? Am I right?
Yes,
2
sir.
bar and okay. Then what is 2 bar
Yes, sir.
plus 3 bar? What is the class? What is the addition of these two classes? I should get a new class, but that class is a member of Z5, right? Okay. Now I will check what is the this. So what is 2 plus 3?
5.
A bar plus B bar is C bar. What is C? Oh, C is a representative of class, but what is C? The number to which A plus B is congruent, modulo 5. So what is
5.
2 plus 3 is 5 and 5 is congruent to 0, modulo 5, and therefore what is 2 bar plus C bar? 2
Zero.
bar plus 3, 0 bar, right?
Robot.
Why 2 bar plus 3 bar is 0 bar? Because 2 plus 3 is congruent to 0 modulo 5. This is the addition of two classes. And is it available in Z5? Yes. This is available in
Yes.
Z5. So addition of two members is a member which is in the Z5 itself. Correct? Now, what is 1 bar plus 2 bar? Now you tell me. What is 1 plus 2? 3. Right? And 3 is
3 bar.
congruent to 3. Right. So the 1 plus 2 is congruent to 3 modulo 5. Right. We cannot reduce it to smaller because 3 is a smaller in this case. So it is 3 bar. So addition of 1 bar and 2 bar is 3 bar, which is still available in Z5. Correct? What is 2 bar plus 4 bar? Now you tell me what is 2 bar plus 4 bar.
1 bar.
1 bar because 2
Yes.
plus 4 is 6 and 6 is congruent to 1 modulo
1 bar.
5. So therefore this is 1 bar. Fine. Now can you work out all the possible additions? You should perform all the possible additions. So let us construct table which will give you some easy way, right? So addition table. So note that so addition defined on Z5 is called as an addition modulo 5. So this addition is denoted by plus addition modulo 5. So this is not like our usual addition. How do we add natural numbers or real numbers? It is something different, right? This is modulo. So when we add two classes, then we look at the representatives and add the representative, and to which that addition, if we add representative, then the sum of representative, its class. What is the class of 6? Class of 6 and 1 is same. Therefore, the addition of two classes is the class whose representative is sum of representatives. Right, and basically what is it? This is 2 plus 4, its class, because class of 1 and class of 6 is same. Right, 1 bar plus 2 bar is basically what? 1 plus 2, whatever is its class, that is means class of 3. Is it clear? Do you understand what I am saying?
Can you repeat that? How the class is same?
See, what is the class of 1? What is the class of 1? 1 plus 5k, if you see the yesterday's discussion. Right, and 6 is in the class of 1 bar. Is it correct?
Yes, sir.
And therefore
Yes.
class of 6 is same as class of 1, because no matter what representative you select, here I am choosing 1 as a representative, I am denoting class by 1 bar. I am identifying class by the representative. But if 6 is a member of class, I can say 6 is also representative. Right, so doesn't matter which representative you select, the class is same. Correct? Therefore, and for simplicity, I am denoting it by 1 bar, because which is easy to work out, right? Because 0 bar, 1 bar, 3 bar. Otherwise, you can say that 0 bar, 6 bar, then 12 bar, but that is something uh, not convenient to observe it or work out with this. So you just denote it by these numbers. So anyway, so this addition is called as addition modulo 5, and we denote it by plus suffix 5. Right, this is a notation because we are adding modulo 5. So what you can do is you can write down addition table. Addition table. And using this table, you can perform all the possible additions. So 0 bar, 1 bar, 2 bar, 3 bar, 4 bar. Here 0 bar, 1 bar, 2 bar, 3 bar, 4 bar. Fine. So what I am going to do, because I am going to do something in very systematic manner, so that you can understand ki what exactly happening. Okay, so what I want now, I want add 0 with 0. So what is 0 plus 0? This is my operation, addition modulo 5. So what is 0 plus 0? What is the class sum of these two classes? Class of 0, right? What is the class of 0 plus class of 1? Do you understand? It is 1 bar.
1 bar.
3 bar. 4 bar. Here also 1 bar, 2 bar, 3 bar, 4
3 bar
bar.
and 2 bar.
Can you fill the remaining boxes? What is 1
Yes.
bar?
Yes.
1 bar plus 1 bar, 2 bar. What is 1 bar
2
plus
bar.
2 bar? 3 bar. 1 bar
3
plus 3
bar.
bar, 1 bar
4
plus
bar.
2, 0 bar. Right? So 2 bar plus 1 bar, 3 bar. 2 bar plus 2 bar, 4 bar. 2
4
bar
bar.
plus 3 bar, 6 bar. 2 bar plus 4 bar, 7 bar. 2 bar plus 4 bar is 1 bar.
Sir,
This is 0, right?
6 bar.
6 bar is 1 bar. Oh, sorry, what is here?
1
2 bar plus 3 bar is 0 bar. 2 bar plus 3 bar. This is what? Intersection of 2 and 3. Correct? What is 2 bar plus 3 bar? 0 bar.
Yes.
And what is here? Here 2 bar plus 4 bar is 1 bar.
1 bar.
What is 3 bar plus 1 bar is 4 bar. 3
4
bar
bar.
plus 2 bar is 0 bar.
0 bar.
1 bar. 2 bar.
1
We
bar.
check this. 4 bar plus 1 bar 0 bar. 1 bar. 2 bar. 3 bar. This is addition. This is called as addition table modulo. And this table gives all possible additions. You choose any two numbers, you can find their addition. For example, you want to see what is 3 bar plus 3 bar. What is, so look at the row of 3 and column of 3 bar. That intersection is 3 bar
1
plus
bar.
3 bar. Right? What is 4 bar plus 3 bar? See the row of 4 bar and column of 3 bar. That is addition. So this table gives you complete addition. So complete addition structure of Z5. Right? So this table gives the everything about addition of two elements in this set. That's why this table gives perfect information of addition. Right? Now just think about multiplication. How do we multiply two classes? So the multiplication of two classes is a new class, but that is congruent, that whose representative is a product of A and B. Next, A bar dot B bar is equal to C bar if AB is congruent to C modulo 5. That's how we define the multiplication. So for example, what is 2 bar into 3 bar? What is 2 bar into 3 bar? So how, what is the new class which is a product? So basically what is it? I will just look at representative. I will multiply representative. Multiplication is 6 and 6 is congruent to 1. Right? And therefore, what is the class? I will multiply representative and there, so
1 bar.
Right? So what is 2 bar into 2 bar?
4 bar.
4 bar.
Right? And therefore it is just class of 2 into 3. It is class of 2 into 2, which is 4 bar. Because class of 2 into 3 means class of 6 is same as class of 1. Right. What is 3 bar into 4 bar? This is product of two classes. And what is the product of two classes? Is a class of their product. Right. And which
2
is
bar.
what?
2 bar.
2 bar. Very, because 3 into 4 is 12 and 12 is congruent to 2 modulo 5. So therefore it is 2 bar. Now what happens 4 bar into 4 bar? What is 4 bar into 4 bar?
4 bar.
1 bar.
1 bar.
1 bar.
1 bar.
1 bar.
Because 4 into 4 is 16 and 16 is
16.
congruent to
And
1
it belongs to 1 bar.
modulo 5. So therefore it is 1 bar. Now write multiplication table that will give you all possible multiplications of elements in Z5. Table. Multiplication table. So this multiplication we denote by modulo 5, or sometimes it is also denoted by multiplication modulo 5, dot modulo 5 or multiplication. So multiplication modulo 5, and you can write down the all possible multiplications. So 0 bar, 1 bar, 2 bar, 3 bar, 4 bar, 0 bar, 1 bar, 2 bar, 3 bar, and 4 bar. Okay, now you fill the table. So 0 bar is 0 bar, 0 bar in multiplied with 1 bar is 0 bar. Right? So this row is 0, this column is 0, this column is 0. And so 1 bar into 1 bar is 1 bar, 2 bar,
1 bar,
3 bar, 4
2
bar.
bar, 3 bar, 4
So 4 bar. Then 2 bar into 2 bar is 4 bar, 2 bar into 3 bar is 1 bar, 2 bar into 4 bar is 3 bar. Am I right?
Yes, sir.
This is 1
Yes,
bar,
sir.
this is 4 bar, this is 2 bar,
4 bar.
right? So what is this? This is 3 bar, this is 2 bar, and this is 1 bar.
1 bar.
Right, so this table gives all possible multiplications. So the complete structure of Z5. Is it clear?
Yes, sir.
Yes. Yes.
How exercises repeat all above for Z7 and Z6. So repeat all above for Z7 and Z6. Okay, Z7, Z6, Z3, Z2. So repeat all above for these 4 sets. You understood what I want now? So you look at Z7. Z7 has how many elements? 7 elements, 0 bar, 1 bar up to 6 bar. And then you understand how to add, how to multiply two members. Right. Now the next question I would like to ask. So what is Z5? So Z5, you know this, 0 bar, 1 bar, 2 bar, 3 bar, and 4 bar. And Z6, for example, 0 bar, 1 bar, 2 bar, 3 bar, 4 bar, 5 bar, right? Now let x is equal to 1 bar in Z5 and y is equal to 1 bar in Z6 is x is equal to y.
No, sir.
Right? So do you understand? They are not same. Is it clear?
Yes, sir.
Yes, sir.
Right? Because this is a class of this is in Z5, so this is a class of 1 modulo 5, and therefore uh, x is equal to 1 bar in Z5. Then what is 1 bar in Z5? It contains multiples of 5 plus 1. Right? It contains 1 bar, 6 bar, not 1 bar, what I want to say, 1,
11.
6,
6,
11, and
11.
so on. But y is equal to 1 bar is in Z6, then 1 bar is 1, 7, right?
13.
13 and so on. And you observe that these two sets are not equal. These two sets are unequal because 6 is in this one bar but 6 is not in this one bar. Moreover, 6 is 0 in second bar, second class, right? So therefore, whatever classes modulo which number, modulo 5 and modulo 6, they are completely different. That you need to understand. This is a simple observation. One more thing, class of 6 in Z6 is 0, but class of 6 in Z5 is
1.
Do you understand? Right. So class of 6 in Z6 is 0, but 0 bar, but class of 6 in Z5 is 1 bar. So therefore, these are completely different. So when I say Z5 or Z6, don't look at the notations 1 bar, 2 bar. Right. 1 bar in Z6 is a different than 1 bar in Z5. 2 bar in Z6 is different than 2 bar in Z5. So this is a simple observation we should remember. Okay. So repeat this addition multiplication for this, right? The same procedure is simple. So let us generalize this idea. Let us generalize this idea. So which idea I want to generalize now is this addition and multiplication. So we have Zn. What is Zn? 0 bar, 1 bar, 2 bar up to
N minus 1.
Minus 1.
So therefore this is a set of classes modulo n. This is a set of classes of congruence relation modulo n. Now from previous discussion idea is clear what I mean to say Zn. These are classes. Now define addition on Zn or addition modulo n as for A bar, B bar in Zn. If you choose any two members A bar and B bar, A bar plus B bar is equal to C bar if A plus B is congruent to C modulo n. For I am fixing n. You fix positive integer n, and with respect to that n, I am not changing. You fix any n, 10, 100, whatever you fix, and I want to make the idea general, means whatever n you select, you will get n classes, and how to define addition on Zn. That is what I want to tell. So define multiplication dot on Zn as A bar dot B bar is equal to C bar if A into B is congruent to C modulo n. So same idea we did for particular 5. So same idea we have to work out for n, and therefore what I want to in this exercise Z7 means what? How do we multiply two members in Z7? For example, A bar and B bar in Z7, right? Then what is A bar plus B bar in Z7? What will be A bar plus B bar in Z7? What will be addition? If it is C bar, then what is C? A plus B is congruent to C modulo 7. That will be the class of A plus B modulo 7. Right. So this will be the class of A plus B. Right. It depends on 7. So A plus B is congruent to C modulo 7. Then A bar plus B bar is C bar. Is it clear now? Similarly for Z6, Z3, Z2. Is it correct? Is it clear?
Yes, sir.
Yes, sir.
Right. So similarly define multiplication on Z7 and so on, and then For general n, this is the addition and multiplication. Right. Now, for x bar in Zn, y bar is said to be, y bar in Zn is said to be an additive inverse of x bar if x bar plus y bar is 0 bar. Right. So what is the additive inverse of y bar? X bar is y bar if x bar plus y bar is 0 bar. Is it clear? Definition is clear. 0 bar is called as an additive identity. In Zn. Why? Why 0 bar is additive identity? Why 0 bar is an additive identity?
Because a plus 0 equal to 0 plus
Yeah.
a equal to a, or all a in R.
Right. Right. So a bar plus 0 bar is equal to a bar for all a bar in Zn. Right, because if you add any element of Zn with 0 bar, it doesn't affect that element. So 0 bar is additive identity. And therefore, what is additive inverse of any member is a y bar if their sum is additive identity, like real numbers. You discuss this idea in real numbers, right? So what is the additive inverse of some element? If added with the element, it will give us additive identity. So now from this previous addition table, can you tell me what is additive identity of 1 bar? What is additive inverse of 1 bar in Z5?
0.
Additive inverse
4.
6
4. 1 bar plus 4 bar is 1 bar plus 4 bar is 5 bar, which is 0,
0.
right? And therefore 1 bar plus 4 bar is 0, therefore additive inverse of.
4.
So 1 bar plus 4 bar is 0 bar, therefore 4 bar is additive inverse of 1 bar, or 1 bar is additive inverse of 4 bar. What is additive inverse of 2 bar? From table it is clear.
3
2 bar
bar.
plus 3 bar is
3
0.
bar.
0 bar and 2
So
bar.
3 bar. Additive. What is additive inverse of 3 bar is 2 bar, and additive inverse of 2 bar is 3 bar. What is additive inverse of 4 bar? 1 bar.
1
1
bar.
bar.
1
Because
bar.
1 bar plus 4. Right. And therefore we got additive inverses of every elements. 1 bar, 2 bar, 3 bar, 4 bar, and 0 bar is 0, right? 0 is identity. So from this table we'll get lot of information, additive inverses and so on. Similarly, what is multiplicative inverse? So y bar is multiplicative of x bar if x bar dot y bar is 1 bar, right? So because 1 bar is multiplicative identity in Zn. So 1 bar is multiplicative identity. And now from this multiplication table, find out multiplicative inverses of various elements and repeat same thing for Z7, Z6, Z and so on. Right? What is exercise? Find multiplicative inverses of elements in Z5 and repeat this for Z7, Z6, Z3 and Z2. Exercise is clear?
Yes, sir.
Exercise. Right. So, okay, we'll stop here. Any doubt?